So here's a kind of tricky conical pendulum example. A conical pendulum is made up of a small particle and a string PQ of length 2.5 meters. The radius of motion is 0.7 meters. The string remains taut throughout the motion. Find the height difference between the particle and the top of the conical pendulum. And secondly, find the tension in the string in terms of m. Hence show the time taken to undergo one revolution is 7 root 2 pi over 10 seconds. So this is quite a complex example, so you can go ahead and try it if you want, and once you've tried it, come back for the solution. So here's our solution. Firstly, we have to find the height. So h squared plus 0.7 squared is 2.5 squared, so the height is 2.4 meters, so something very basic. Next, the forces up equals the forces down, so t cos theta is mg. So cos theta is 24 over 25. So the tension in the string is 25 mg over 24 newtons. Next up, we have the centripetal force is mv squared over r. Since we're not technically looking for omega or v, but I just tend to like using v if there's a choice. So therefore t sine theta is mv squared over the radius, which is 0.7. So sine theta is 7/25, so 7t over 25 is mv squared over 0.7. But we know what t is, it's 25 mg over 24. So substituting that in, we can cancel the 25s here, and the m's on both sides. So we get 7g over 24 is v squared over 0.7. So when you actually do this, you get a number that is very close to 2. It's 2.000833. So it's pretty much 2 to any sort of degree. So the velocity is root 2 meters per second. So one revolution is 2 pi by the radius, so 1.4 pi meters. So time is distance over the linear speed. So it's 1.4 pi over root 2, which simplifies to 7 root 2 over 10 times pi seconds, which is exactly what we were looking for.